Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 3 of 5 good problems on the chapter of time and work. I have already completed set 1 and set 2 of 5 good problems. If you have not watched those 2 videos, I highly recommend and suggest that you please watch those videos as well. And also I have already completed the theoretical aspects of the concept of time and work in the other playlist, that is CBSE Maths 8 R.S. Agarwal. You can also watch those videos in that playlist. This video is part of the playlist Maths 8 Hot, where HOT stands for High Order Thinking, where I come up with 5 relatively harder problems from every chapter as and when they are completed in the other playlist CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 3 on the chapter of time and work. Okay, so I have written down all the 5 problems of set 3. I will solve them on the right hand side. On the left hand side, you can see the list of key concepts and formulas that I have prepared on the chapter of time and work, and each concept uh, is numbered so that I can, using that number, and also each concept is part of a number and a subpart, that is 1A, 1B, 1C, or 2A, 2B, like that. I will refer this number of the concept that I will apply at a particular step in solving a problem, so that it will be easier for you to correlate the concept and the solution. Okay, so let's start solving the problems. The first problem says uh, A can complete A can complete a work in 6 days, while B alone can complete the work in 12 days. Okay, if they work together and completes the work, then the portion of the work done by A is. Okay, so if they work together and completes the work, then the portion of the work done by A is, that is the portion of the portion of the total work that has been done by A. The total work we always consider it as 1, and so definitely the portion of the work done by A will be a fraction of the total work, which is 1. That is, it will be a fraction, and the work done by A and the work done by B, that is the fraction of the work done by A plus the fraction of the work done by B in completing the work should be equal to 1. Okay, so how do we proceed? We need to find the portion of the work done by A. The way the concept is that first we will need to find in how many days the total work was completed by A and B together. If from the number of days, then we will find in that number of days how much work A has done, because we know that in one day it is given that A can complete the work in 6 days and B alone can complete the work in 12 days. Okay, so let's start solving the problem step by step. So we can say that is 1 day's work, 1 day's work will be equal to 1 by 6. This is based on the concept that I've applied is 1A. This is concept 1A, that is, if a piece of work can be done in n days, then amount of work done in 1 day is 1 by n. So A's 1 day's work is 1 by 6. Similarly, B's 1 day's work is equal to 1 by 12. This implies that A plus B's 1 day's work, that is the amount of work done by both A and B working together in 1 day, this should be equal to 1 by 6 plus 1 by 12. This is applying the concept. Uh, Here also we applied the concept of 1a, and a plus b is 1 day's work is equal to 1 by 6 plus 1 by 12. This is based on the concept. We could have come to this fact that a plus b is 1 day's work is 1 by 6 plus 1 by 12, applying the concept directly free. But anyway, where is that part? Okay, so I think for in the concept document list of concepts, there should be another concept that if A does, that is the work done, amount of work done in 1 day by A and B is equal to amount of work done by A in 1 day plus amount of work done by B in 1 day. This concept is not there in the document. I will add it anyway. So I'm not writing any referring any concept here. So this is this 1 by 6 plus 1 by 12, and this is equal to 2 plus 1 by 12, 3 by 12, which is 1 by 4. So from here, we can say that now I will not, please note that I will not describe much regarding the concept applied at every step. I will, instead of talking, I will refer the concept number so that you can look up the concepts document and understand what concept was applied. Please keep a copy of this PDF on the left hand side that I am referring, so that you can also refer the document while you are watching the solution. Okay, so now I can say that time taken by a plus b a plus b a plus b means a and b working together. Time taken by a plus b to complete the work will be equal to 4 days. 4 days. The concept applied here was, I think I wrote this concept. Yes, the concept number 17 and 18, these are in terms of hour. The time is hour, but it will also work for days. So from the fact that a plus b is 1 day's work, that is the amount of work done in 1 day is 1 by 4. From this fact we can say that the total work will be done in 4 days. I am applying the concept 17. Applying the concept 17. So we know that A and B has worked for 4 days to complete, will have to work for 4 days to complete the work. Okay, so this implies that A has worked for 4 days with B to complete the work. That is, together when A and B was working, they took 4 days to complete the work. So we can say that A and B both have worked for 4 days to complete the work. Okay. Now we need to find what is the amount of work done by A in 4 days. Okay. So from the fact that A is 1 day's work is 1 by 6. So we can say that we can say that A is 4 days work is 4 days work will be equal to 4 multiplied by 1 by 6. 1 day's work is 1 by 6. So from simple unitary method we can say A's 4 days work will be 4 into 1 by 6. There is also a concept I have listed down, I think. Let me check. Uh, mm, whole work, rate of work. Mm, No. Well, this is simple unitary method, that if A is 1 day's work is 1 by 6, then A is 4 days work will be 4 multiplied by 1 by 6, and this is equal to 2 by 3. So so A is 4 days work is 2/3. So this implies that A's total work in completing the work with B in 4 days is equal to 2 by 3. So 2 by 3, that is 2 by 2 by 3 fraction of the total work was done by A in 4 days in completing the work. Similarly, we can say that the remaining work, that is 1 minus 2 by 3, which is 1 by 3, that is 1/3 of the total work, was completed by B. So the correct choice is D. D is the correct choice. Okay, let's do the next problem. Uh, a tap can fill an empty tank in 48 minutes, whereas another tap can empty the filled tank in 2 hours. Okay, so we have two taps. The first tap is an inlet and the second tap is an outlet. The first tap fills completely an empty tank in 48 minutes, and the second tap, which is an outlet, completely empties filled tank in 2 hours. Now the time given is in hours as well as minutes. I think it will be better if we okay, so let's see. If both the taps are opened at 4:40 p.m., then the tank will be filled at. Okay, so first we have to find in how much time both the taps A and B are working together. That is, when both are open, how much time they will take to complete the tank. Completely fill the tank. Okay, so let's name the tap. Let's say this tap be A, and another tap, let's say this tap be B. That is, the inlet is, let the inlet be A and the outlet be B. So we have this tap B. Okay, so we know that the work done by tap A in let's assume use the unit of time as minutes. Work done by tap A in 1 minute is equal to 1 by 48. This is using the concept of 10A. Concept of 10A, that is, if a tap can fill an empty tank in n hours, then work done by tap in 1 hour is 1 by n. Now this is in the example, in the concept document I've used hours. It can be any other unit of time, that is, it could be minutes. Okay, so work done by tap A in 1 minute is 1 by 48. Similarly, work done by tap B, now tap A was an inlet, so the work done was positive. Now tap B is an outlet, and the work done will be negative. Now what will be the work done? Now first we have to convert the 2 hours as minutes. So this will be negative of 1 by 2 hours is 2 hours in minutes is 2 multiplied by 60. This is equal to minus 1 by 20. Negative of 1 by 20 is the work done by the outlet tap B in 1 minute. Okay, now now we have to see okay, so now we have to find what is the work done by both the tap A and B, that is, when both of them are functional, or both the tap A and B are working, or both the taps A and B are open. So work done by A plus B, that is both the tap A and B are open or both the tap A and B are working together. Work done by A plus B in 1 minute will be equal to, the work done will be 1 by 48 minus 1 by 20. Actually it is 1 by 48 plus it is the work done by tap A in 1 minute plus work done by tap B in 1 minute, which is 1 by 48 minus 1 by 120. Now here the concept applied was 12. Concept 12 says that if work done by tap A in 1 hour is X, now instead of hour it could be minutes, and the work done by tap B in 1 hour is Y. So the work done by tap A plus B, that is when both the taps A and B are open in 1 hour, will be X plus Y. Okay. Now what is this? 1 by 48 minus 1 by 20. What will be the LCM? LCM. Okay. 40. LCM will be 480, I think. Uh, 48 is equal to 12 into 4, and 120 is equal to 12 into 10. So we have to find what will the LCM of 48 and 120. It will be, so LCM of 48 and 120 will be, I'm not really using the common calculation of finding LCM, I'm just roughly finding the LCM of 48 and 120, even though you must be able to do it verbally in the mind, but I am not that smart, so I am doing a little bit of calculation. Okay, so it will be definitely 12 multiplied by the LCM of 4 and 10. What is the LCM of 4 and 10? 20. Okay, so eventually this is 240. The LCM is 240. Okay, the LCM is 240. 240. This will be, I guess, 5, and this is 2. Okay, so this is 3 by 240. This is equal to 1 by 80. So the work done by the tap A plus B in 1 minute is 1 by 80. Okay, so now from here we can say time taken by A plus B, that is when both the taps A and B are working together, or both of them are open, time taken by A plus B to completely, remember that the work done, please note that the work done in 1 minute by A plus B is positive, that is 1 by 80. This means that per minute, that if when both these taps are open, per minute when the tank is empty, per minute the tank will be filled by some water, and it was since the work done is positive, and if the work done by A plus B in 1 minute was negative, that would mean that per minute some water is being emptied from the tank. Okay, so time taken by A plus B to completely fill the tank will be equal to 80 minutes. This is using the fact you can say using the concept 17, that is if in 1 hour, in the concept it is an hour, but it could be instead of hour it could be minutes as well. So if 1 hour 1 by n work is done by some steps, then whole tank will be filled in hours. Now remember that in the concept 17, n is a positive number, and concept 18 says if in 1 hour minus 1 by n work is done by some taps, then the whole tank will be emptied. Since the work done in 1 hour is negative, that is minus of 1 by n, it will mean that the whole tank will be emptied in n hours. Okay, 80 minutes. So we see that the whole tank will be filled or in 80 minutes. Now the problem says that if both the, now we have to see, we okay, 80 minutes. Now let's convert these 80 minutes in hours and minutes. So this is 1 hour 20 minutes. 1 hour 20 minutes. Now the taps, both the taps were opened at 4:40 p.m. So after 1 hour and 20 minutes, the tank will be filled. So what is the time? What will be the time when the tank will be filled? The time will be 1 hour 20 minutes after 4:40 p.m. Okay, so this implies time at which tank will be filled should be equal to uh, 4 hours, since the time at which the taps were open was 4 hours for 40 minutes. So 4 hours, 4 hour 40 minutes, and then it should be plus what, I am not sure whether I am this way of calculating time, calculation of time is correct or not, but I hope you will understand. 1 hour 20 minutes, this is equal to now 5 hour 60 minutes, this is equal to 6 hour. So ideally, not 6 hour actually, I'm using this tilde sign. Tilde sign means approximately equal to. So this is basically 6 p.m. So at 6 p.m. The taps were open at 4:40 p.m. and it took 1 hour and 20 minutes for by both the taps to completely fill the tank. So at the time 1 hour 20 minutes after 4:40 p.m. is 6 p.m. 6 p.m. So at 6 p.m. the tank should be filled, completely filled, and hence the correct choice should be choice B. Okay, let's solve the next problem. A and B working together completes a job in n days. If total work done by A and B are in the ratio x is to y. Okay, that is the total work done by A and B in, so A and B has worked, so A and B completes a work in n days. So that means once they complete a work, they have worked for n days. In those n days, A has done some part of the work and B has done the remaining amount of work. The ratio of those work, the ratio of amount of work of A and the amount of work of B done in n days is given to be x is to y. Then time taken by B alone to complete the work is. Okay, so okay, so let's start from the given ratio, that is the not a ratio of the work done by A and B. So okay, so we know when we solve problems on ratio, that is the ratio of two quantities are given and we need to find those two quantities, we assume those two quantities are based on the parts of the ratio. Now let's say let amount based on the ratio, we are assuming let amount of work done by A. Now this amount of work done is the total amount of work done by A in completing the job. So let amount of work done by A, let's say in completing the job, let amount of work done by A, let's say A and B in completing the job B, the ratio is given to be x is to y, so we will assume xt and xt and yt, where t is some variable, we need to find it respectively. That is, we have assumed that based on the given ratio x is to y, we are assuming the total work done by A in completing the job is xt and the total work done by B in completing the job is yt. Okay. Now, please remember that we must have xt plus yt should be equal to 1 because whole work is 1. Whole work is 1. So we must have the amount of work done by A plus the amount of work done by B should always be equal to 1 because they both have completed the job. That is, both of them has done the whole work. So this implies that t into x plus y is equal to 1. This implies t is equal to 1 by x plus y. So we know what is t. So now we can say that amount. The question has asked then time taken by B alone to complete the work. Now we can find the time taken by B alone to complete the work if we can somehow find what is the work done by B in 1 day. So that is what we are trying to find. Now from this fact we have found T. Now we can say that amount of work done by B in n days. Why? Because A and B together can complete the job in n days. So and in n days, and we have assumed that the amount of work done by A and B in completing the job, that is in completing the job means after working n days. Okay, so amount of work done by B in n days will be now equal to yt as per our assumption based on the given ratio. So this is equal to y into t is 1 by x plus y. This. So amount of work done by B in n days is y by x plus y. Now, so we have B's n days work is equal to y by x plus y. So in n days, the amount of work done by B is y by x plus y. Okay. This implies B's 1 day's work using simple basic unitary method. We can say that B's 1 day's work will be y, whatever the work done in n days, these are divided by n. This is equal to y by n into x plus y. So B's n days work is y by x plus y. So B's 1 day's work will be, we just need to divide by n. This is basic concept of unitary method. So we have y by n into x plus y. Now from this fact we can clearly now say that B alone will complete the job in. Now this y by B is 1 day's work. 1 day's work, it is always preferable to be to express in the form of 1 by n. So y by n into x plus y, this can be written in the form of y by n as 1 by n into x plus y divided by y. So now we can say that B alone will complete the job in n into x plus y divided by y days. This is based on the concept of uh, concept we applied is mm, if from the amount of work done in one day, we always can find the number of days required to complete the whole work. So if one day's work is if the amount of work done in one day by one man or any other for more than one man is 1 by n, is in the form of 1 by n, then we can say that the total work will be done in or will be completed in days. Okay, so this was the concept. Uh, mm, 2a. So 2a. So the answer should be n into x plus y divided by y. N into x plus y divided by y. So the correct choice is C. C is the correct choice. Okay, let's move on to the next question, which is question number 4. A is thrice as good as a workman as B, and so takes 60 days less than B for doing a job. And so takes 60 days less than B for doing a job. Okay. A is thrice as good as a workman. Now, what does it mean? A is thrice as good as a workman. Okay. The time in which they can do the job together is. Okay. Now, we need to understand what is meant by the fact that A is thrice as good as a workman as B. What information can we say based on this? A is thrice as good. Definitely, this means that A is working 3 times faster than B. You can consider this as A works thrice as fast as B. You can consider this. A is thrice as good as workman as B means you can consider that A works thrice as fast as B. Now you can also consider, you can also from this fact that A is thrice as good as a workman as B, you can also, this also means that A does 3 times the work done by B in completing a, job. Now I think this will be more preferable. Okay. Now it is also given. It is the problem also says that A takes 60 days less than B for doing a job. A takes and so takes 60 days less than B for doing a job. So let's say okay, so let's say let B takes X days to complete the job. Now B takes X days to complete the job. Okay. Now we can say that it is given that A takes 60 days less than B. So this implies that A takes 60 days less than B. So B, we are assuming B to be taking, B takes X days to complete the job. So therefore A takes X minus 60 days to complete the same job. Now this is one information we have. Assuming that, based on the assumption that B takes X days to complete the job, we know that as per information given in the problem, we know that A will take X minus 60 days to complete the job. But we also know that A will work thrice as fast as B, which means that A will take whatever time B takes, but whatever time B takes to complete the job, A will take the 1/3 of the time. So from this, we can say that time taken by A to complete the job should be equal to time taken by B to complete the job divided by 3. Please note, it is important to understand that the given fact was A is thrice as good as workman as B. This means that A works thrice as fast as B. Good means A is doing more work in a given time, which essentially means that A is working faster. So we can say that A works thrice as fast as B. Now this also means that the time taken by A to complete the job will be 1/3 the time taken by B to complete the job. Now from this we can say, we know that time taken by A to complete the job is X minus 60. So X minus 60 should be equal to time taken by B to complete the job. We have assumed that to be X by 3. So we get a linear equation in X, and we can easily solve for X. And once we solve for X, we will know that how many days A and B alone can complete the job, and from there we can easily find out what will be the time taken by both A and B together to complete the job. So let's first solve the linear equation. So doing cross multiplication, we have 3 into X minus 60 is equal to X. This implies 3X minus 180 is equal to X. This implies 2X is equal to 180. This implies X is equal to 180 divided by 2, which is 90. So X is 90, and I have no more space. I have to now struggle with the space. Let me see. Now we see that this implies B takes 90 days to complete the job, that is to complete the job alone, and A will take X minus 90, that is 90 minus 60, that is 90 minus 60, or 30 days to complete the job. Now this implies what will be the work done by A plus B in one day. Work done by A plus B, that is when both A and B are working together, work done by A plus B in one day will be equal to 1 by 90 plus 1 by 30. This is applying the concept of concept number 3. This is equal to 1 by 90 plus 1 by 30 is how much? 1 plus 3 by 90, this is 4 by 90, this is 2 by 45. Now work done in one day, it's preferable to express that in the form of 1 by n. So 2 by 45 is equal to 1 by 45 by 2. So work done by A and B, both A and B working together in one day is 1 by 45 by 2. So now we can say that what is happening? We can say that now time taken by A plus B to complete the job will be equal to 45 by 2 days. 45 by 2 days. This is based on the concept of, you can say, 2A. Concept 2A. I'm really sorry for my clumsy solution. I hope you will be able to make it out. So 45 by 2 days. In 45 by 2 days, A and B together, working together, will be able to finish the job. Now 45 by 2 days, let's convert it as a mixed fraction. Let me see what are the choices given. Okay, so 45 by 2 days will be equal to 22 and half days. So 22 and half days should be the answer, and hence the correct choice is A. A is the correct choice. Okay, let's do the last problem. A and B together can do a job in 7 days. A is 1 and 3 by 4 times as efficient as B. Okay, the same job can be done by A alone in how many days? Okay, so the efficiency of A is 1 and 3 by 4 times as B. Okay, now efficiency we know, as we know, is the amount of work done in one day. So efficiency of A and B, that is efficiency of A will be the amount of work done by A in one day. Also the efficiency of B will be the amount of work done by B in one day. I hope there is a concept. Rate of work efficiency is amount of work done in 1 unit of time. Now since it is given that A's efficiency is 1 and 3/4 times as efficient as B. So let's assume let efficiency of B be X. Now efficiency is basically amount of work done in one day, which should be a fraction. So we are assuming that efficiency of B be X. As per the given problem, we can say that A's efficiency will be equal to 1 this times X. Now 1 and 3/4 times X. So this is equal to 7 by 4 multiplied by X. This is 7x by 4. So efficiency of B as per our assumption is X, and as per then we can say from the given problem A's efficiency will be 7x by 4. Now we can say that work done, efficiency means work done by B in one day is X, because this is the definition of efficiency. Similarly, work done by A in one day is equal to 7x by 4. Now this implies Uh, Now, for this work done, when we are saying that work done by B in one day is X, which is the efficiency of B, the concept I applied is you can consider as concept 5. Concept 5. Okay. So now work done. Work done. Oh, what is said? The same job can be done by A alone in how many days? So to find that, we have to find what is the amount of work done by A in one day. So we need to find X. Now how do we find X? We have to use the information that A and B together can do a job in 7 days. You have to use this information. Now let's see what is work done by A plus B, that is when A and B are working together. A work done by A plus B in one day will be equal to X plus 7x by 4. This is equal to 4x plus 7x by 4. This is equal to 11x by 4. Okay, now work done by A plus B in one day is x plus 7x by 4. That is, we added the amount of work done by B in one day and the amount of work done by A in one day. So the concept applied is this concept is not given in the document of keys and concepts and formulas. I will add it later on. You can you can also consider. No, I will add this concept, that is regarding a mean and work. If work done by A in one day is X and work done by B in one day is Y, then the work done by A plus B in one day will be X plus Y. So that is the concept applied. Have applied when finding the work done by A plus B in one day, which is X plus 7x by 4. Okay. So now from the fact that work done by A plus B in one day is 11x by 4, which I would like to express it in the form of 1 by n. This is 1 by 4 by 11x. 11x by 4 is equal to 1 by 4 by 11x. Now we can say that time taken by A plus B, to complete the job, will be equal to 4 by 11x, using the concept of uh, you can say the reverse of not reverse. I added two more concepts in this document, which is 17 and 18. Even though the concepts of 17 or 18 are related to taps, but it will also we can also no, these are concepts based on tanks and pipes, 17 and 18. I think you can consider the concept applied is one. If a piece of work can be done in n days, we know that the amount of work done in one day is 1 by n. The reverse is also true. That is, if we know that the amount of work done in one day is 1 by n, then we can say that the total work, the whole work, will be done in n days. So I am writing it as 1a. So we have time taken by A plus B to complete the job should be 4 by 11x. But in the problem it is given that A and B together can do a job in 7 days. So we can say that 4 by 11x should be equal to 7. So this implies x will be equal to 4 by 11 into 7. This is equal to 4 by 77. X is 4 by 77. So we have found x. Now the question is asking the same job. The question is asking in how many days A alone can complete the job. So for that we need to know the work done by A in one day, which is 7x by 4. So this implies A's one day's work is equal to 7x by 4, was 7x by 4. This is equal to 7 by 4 multiplied by x is 4 by 77. This is equal to 1 by 11. Now we can say that time taken by A alone to complete the work is equal to 11 days, based on the concept of based on the concept of 2a 2a. That is, if the amount of work done in one day is 1 by n, then the whole work will be completed in n days. So we had that A is one day's work, that is the amount of work done by A in one day is 1 by 11. So the whole work will be completed by A in 11 days. So 11 days should be the answer, and the correct choice should be choice B. So this brings to an end in solving another set of 5 good problems on the chapter of time and work. I hope solving this problem will give you a good practice and evaluation of your understanding of the chapter concepts. I will come up with more sets of this kind of 5 good problems on this chapter. So please stay tuned and keep an eye on this playlist. And so if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. One thing I would like to say, that in between I have forgot to prepare and solve 5 good problems on the chapter of direct and inverse variation. I already prepared the set of problems, but I forgot to solve and make the videos. So I will very soon, I will solve 5 good problems on the chapter of direct and inverse variation. That was skipped. I'm sorry for that. So very soon, those videos will come on 5 good problems on the chapter of direct and inverse variation on this playlist, that is Maths 8 Hot. So I will end the video here. I hope this video was beneficial, and thanks for watching, and until the next video, take care and bye.